Hey, welcome back. This is a second video on higher order derivatives. Here we're asked for the second derivative of an expression whose first derivative and second derivative will require a chain rule. So when we take the first derivative, we recognize this as a w to the power of 3 over 2 of a function. So when we take the derivative, the 3 over 2 will come down. We'll have the original function in brackets, x squared plus 9, to one lower power, 3 over 2 minus 1, which is 1 over 2, multiplied by the derivative of the inside, which is 2x. Now, one thing we can do is we can simplify. We can multiply the 3 over 2 times the 2x. We'll put those pieces together. So we'll have x squared plus 9 to the power 1/2 multiplied by 3x. Now for the second derivative, we have to use what rule? In addition to a chain rule, we're going to have to use a product rule, a times b. Make sure I label that in the last one. So a times b prime plus b times a prime. So a is x squared plus 9 to the power 1/2. I'll leave a spot for b prime. I'll just put it there. It's 3. Derivative of 3x is 3 plus b, so 3x. I'll leave a spot for a prime. I'll calculate a prime off to the side. A is equal to x squared plus 9 to the power 1/2. A prime we'll need the chain rule. The power will come down. X 1/2 times x squared plus 9 to the negative 1/2. Power gets reduced by 1, so subtract 1. 1/2 minus 1 is negative 1/2 times the derivative of the inside. And then we can simplify by multiplying. Well, we don't even have to, but I will. We have x squared plus 9 negative 1/2, and then 1/2 times 2x is just x. And I'll attach an additional instruction here. I'll say do not simplify. And do not simplify would mean leave it like this. Don't mess with it. All right. Some more code words. These code words have been mentioned already. One of them being velocity, the other one being acceleration. In the math class, velocity just means first derivative, and acceleration just means second derivative, and don't interpret it any other way. So again, if you're asked for the velocity of something and you're given a position function, take the first derivative of that function. If you're asked for the velocity at some instant, after you take the derivative, plug in t. Plug in the number. For acceleration, it's the same thing. It's the second derivative, so I'll take the derivative once to get the velocity, take the derivative again to get the acceleration, and if you're asked for the acceleration at a particular moment, say at t is equal to 5, well, after you do the second derivative, plug in 5. So concrete example. You may not even be able to do this one this year if all you have is an ebook, because that would mean throwing your computer up in the air. It's a great loss. A math textbook is tossed aggressively into the air from the top of a 40-meter building. The height of the book from the ground below is given by h of t is equal to minus 5t squared plus 20t plus 40. Find the velocity and acceleration after 1 second and after 3 seconds. So we're going to have some derivatives to do and some evaluations to do. So v of t is equal to h prime of t which is negative 10t plus 20. Now we want to evaluate this at 1 second, so v of 1 is equal to h prime of 1, which is negative 10 times 1 plus 20, which is 10. V of 3 is equal to h prime of 3, so negative 10 times 3 plus 20, which is negative 10, negative 30 plus positive 20. And if you're interested in the units, these units would be meters per second. Now we want acceleration. A of t is equal to h double prime of t. So that's the derivative of negative 10t plus 20. That's negative 10 plus 0 is equal to negative 10. And then we want the acceleration at those times. A of 1 is equal to h double prime of 1, which is just negative 10. There's no t left, so the acceleration is always negative 10, including at time 3. So h double prime of 3 is equal to negative 10 as well. And these are usually a little bit more interesting with the t survives. But this one's realistic. This would fairly accurately describe the height of the book if it was thrown straight up in the air. And it's worth mentioning that after 1 second, the positive velocity of 10 means it's still going up, so gaining height 1 second after being thrown. At 3 seconds, the negative velocity means it's hit its peak and it's on its way down now. It's getting closer to the ground, not further away. What do you think happens at 2 seconds? So that's for you. Homework. Find v at 2 and interpret. Part 2 is a challenge. What is the max height of the book above the ground? That's not that hard to do if you know what you're doing, but I'm calling it a challenge because it's a bit of a preview. It's not perfectly aligned with where we are in the course. All right, much better. A jet-powered banana. Perhaps the banana used in the modeling of demand for knobs. A jet-powered banana's height above the ground in meters at t seconds after activation of the jet engine is given by that expression. Find the times at which the velocity of the banana is 0. Different problem. All right, we got to find the velocity first. So v of t, that's h prime of t, the derivative of the position function, or the height function in this case, 0 minus 60t plus 30t squared. Okay. Want values. Could be one value, it could be several value of t when v of t is equal to 0. So 0 is equal to negative 60t plus 30t squared. We're going to solve this by factoring. If you solve it by rearranging and canceling, you might throw away solutions. So 0 is equal to, I'm common factor out a 30t, and I have negative 2 plus t left. And we've set this equal to 0, so we have two different possibilities. to get 0 on the right hand side to match the 0 on the left. Either 30 times t is 0, which means t is equal to 0, or negative 2 plus t is equal to 0, which means t is equal to 2. Now the second part, find height at t equals 0, t equals 2. So h of 0, that's going to be easy. 60 minus 0 plus 0, which is 60. The other one might be a bit of a mess. H of 2 is 60 minus 30 times 4 plus 10 times 8. 2 to the power of 2 is 4. 2 to the power of 3 is 8. So 60 minus 120 plus 80, that's 20. So the height at time t equals 0 is 60. The height at time t equals 2 is 20. And both of those heights, the velocity is 0. Find the time at which the acceleration of the banana is 0. And it asks what is the velocity at that time and what is the height above the ground at that time. So let's find the acceleration. A of t is equal to h double prime of t. So we take the derivative of negative 60 plus 30t squared. We get the negative 60t plus 30t squared. We get negative 60 plus 60t. We want time at which acceleration is 0. So 0 equals negative 60 plus 60t. We'll factor out a 60. Negative 1 plus t. So we get t equals 1. Okay, and now we want to find velocity and height at this time. Find v of 1 and h of 1. So v of 1 is negative 60 times 1 plus 30 times 1 squared. So negative 60 plus 30 is negative 30. And h of 1 is 60 minus 30 times 1 squared plus 10 times 1 cubed, which is 40. And it'll just circle all the things that would count as final answers here. Final answer, final answer. Those are final answers. This is a final answer. And those are final answers. All right. So second derivatives or higher derivatives can be combined with implicit differentiation as well. We saw it combined with chain rule. Now we're going to see it combined with implicit. So we're going to start by taking the derivative once. We're going to take the derivative with respect to x, treating y as a function. X is a variable. We're taking the derivative with respect to the x variable. So when we differentiate, we get 2x plus 2y y prime is equal to 7 minus 3y prime plus 0. Derivative of 100 is 0 since 100 is a constant. Now we want to collect like terms, all the y prime pieces on one side, the pieces without y prime on the other. So the 2y y prime can stay where it is. I'm going to add 3y prime to both sides, equals 7 minus 2x. Subtracting 2x from both sides, move it over to the right since it does not contain y prime. Now I'm going to isolate, or not isolate, I'm going to common factor y prime out. So we get 2y plus 3 equals 7 minus 2x. Then do one more thing, divide both sides by that bracket term to get y prime all by itself. So now we don't have y double prime, we have y single prime. Now we're going to take the derivative again on both sides. The derivative of y prime is y double prime. And we have a quotient rule. This is a t over b, a top function over bottom function. So when we take the derivative, we'll have bt prime minus tb prime all over b squared. And you have to watch for quotient rules for higher order derivatives as well. There's a few in the homework, and they're important. So the bottom function, 2y plus 3 times t prime, 0 minus 2, minus t, the top function is 7 minus 2x, and then the derivative of the bottom. What's the derivative of 2y? It's not 2, it's 2y prime. And the derivative of 3 is 0, since 3 is a constant. And then all divided by the bottom squared, so 2y plus 3 all squared. And I'm going to add something to this question. I'm going to add an instruction. One of my favorite instructions says do not simplify. It would be expected you would leave it like that. And we'll have multiple choice problems that are left that way. That are left all expanded out, not simplified, because we don't want you to spend time on that. You'll run out of time if you try to simplify everything. All right, and then the last question, I believe, yes, last question, find y double prime in this case. So we'll take the derivative the first time, treating y as a function, x is the variable, taking the derivative with respect to x. Derivative of 8 is 0. Derivative of x to the 3 is 3x squared. Derivative of 1000x is 1000. Derivative of y to the 4 is 4y to the 3 times y prime. Now I'm going to rearrange. I'm going to bring all the y prime terms to the left. The terms without y prime moving to the right. So let's add 4y cubed y prime to both sides. 4y cubed y prime. And let's add 3x squared to both sides. 1000 plus 3x squared. I'm going to isolate by dividing both sides by 4y to the power of 3. So 1000 plus 3x squared divided by 4y to the power of 3. And now we have to take the derivative again with a quotient rule. Top function over bottom function, quotient rule. So we'll have bt prime minus tb prime all over b squared. And we'll plug in the pieces. The bottom function is 4y to the power of 3. And the derivative of top is 0 plus 6x minus the top, 1000 plus 3x squared. And then the derivative of the bottom is 12y squared times y prime, and then all divided by bottom squared 4y cubed all squared. And it'll also say do not simplify. And I'll add a second instruction. I'll say do not simplify. And leave your answer in terms of x, y, and y prime. Because what sometimes the textbook does, and what I don't want you to be tempted to do unless told otherwise, is they might take this expression, my laser pointer, for y prime, it's over here, and they might then go back and replace that with this. Please don't do that unless it specifically says put it only in terms of x and y. If it doesn't say that, it's just extra work. It's not necessary. All right, that's it. Take care and see you next time.